So good morning, ladies and gentlemen, and thank you for the presentation. Foam, it's a very unwanted in paper and board industry. And a lot of effort has been made in order to kill it or in order to prevent its formation. But as you heard from the previous presentation, foam can be very beneficial. It offers several advantages, both in product or sorry, I should take this away, process development point of views. And in this presentation, I will tell you how we utilize foam in the surface treatment of paper. The outline of the presentation is that first I go through some principles and then the benefits, why do this, and then I will show the facilities we have and of course some results, and in the end, conclusions. So we have now exciting new materials, but how to utilize them? How to use them in order to develop new materials or new product, or how to use them to enhance the existing ones? The conventional coating methods, they may be a question mark. The new materials, they may have some challenging properties like high viscosity in a low solid content, as nanocellulose, or they can be very expensive ones. And it could be possible that when we put these new materials to the normal coating recipes, very complex recipes, we can destroy the functionality what we have created to these new materials. That means that we need novel coating methods, these application methods. And one solution for that is foam coating. It's a technology that is used in textile and nonwoven industry. In foam coating, this foam is used as a vehicle, as a carrier phase to transfer the material to the substrate surface. We produce the foam by mixing the starting material, foaming agent, and pressurized air in a special foaming generator. There is a rotor-stator mixing head. And the foam produced contains 90% of air, 95% of air. And there is some pictures showing that what kind of foams we use. The left-hand side is a wet foam, and that is used in the foam forming of paper. The air content of that is around 60-70%, and the shape of the bubbles is round. The right-hand side is a coating foam. The air content is higher, about 90-95%, and the bubbles are like a honeycomb. And if the material what we want to apply to the surface contains particles or fibers, these are located between the bubbles or in the bubble pockets, and that means that the bubbles keep them apart, so they prevent the flocculation of the fibers or aggregation of the particles. The application itself is done by a narrow slot type applicator. And when the foam comes out of the applicator, the bubbles collapses to the absorption of the paper surface, leaving the material on the paper surface. So why do this foam coating? What are the benefits? At first, it's a non-contact coating method. And that is very important when we have nanomaterials. There is also no side streams, meaning that all of what you apply goes to the paper web, and you don't need to circulate the coating material. This technology also allows very thin coatings, from 0 to few grams per square meter. And we can apply these small amounts evenly to the surface, because when the foam has air content of 90%, that means that instead of 1 micrometer layer, we apply 10 micrometer layer. And also there is less tendency to migrate these materials into the substrate. We can also apply gel-like materials like this nanocellulose as just. We don't need to dilute it. And when we apply nanomaterials, we don't need any binders. That means that the coating recipes can be very simple ones. And it's also possible to create functionalities to the paper surface using functionalized materials. This technology is also very versatile. With this same equipment, it's possible to apply different kinds of materials. And also we can use higher concentrations if we compare this technology, for example, to spraying. And I want to highlight that this technology is also occupational healthy method because there is no airborne particles. Very important thing if we think about these nano-scale materials. So for foam coating research, we can offer several possibilities from pilot scale to small scale research, meaning, for example, material research. We have proven this technology in pilot scale, and the possibilities what we have different kind of foam generators and 2 applicators. But what is also important, we have different research environment, because foam coating can be done to the dry web or wet web. For wet web applications, we have this VTT Suora. You already heard about that in the previous presentation. And the smaller scale environment is VTT Kisu, which is also working in the foam forming mode. For dry web applications, we have VTT Sutko coating line. And for that, my colleague Vesa Kunnari will tell more about that environment. And also KCL pilot coater, what is a mill scale coating line. The only exception is that the wet whip is only 0.5 meter. VTT is coordinating a EU project SunBub, and in that project we have applied nanocelluloses on the fine paper surface. You can see from the left-hand side picture that nanocellulose in solid content of tree is very viscous. It doesn't flow itself to the from the feeding tank to the pump, so it really needs some pushing. But after the foam process, it's an excellent material for application. And we have applied that to the surface of paper. The SIM images shows that, the left-hand side picture, that the nanocellulose is covering the paper surface, making it smoother and the separate fibers are not so visible. And the coating amount is below 1 gram per square meter. But what was surprising in this, that even so thin layer can change the paper surface properties. Depending on the nanocellulose types, there is a contact angle results. Some of them change the surface more hydrophilic, and one type close the surface. We have also applied modified nanocelluloses. Here are some results from the zinc oxide modified. Zinc oxide is antibacterial, and this result shows that this foam-coated, this thin layer of zinc oxide modified nanocellulose has a significant antibacterial properties against these 2 different bacteria. Also, we have applied titanium oxide, and these results shows that titanium oxide, there are 2 results from different coating trials, that this titanium oxide nanocellulose has a significant activity for the oxidation of nitrogen oxides. So, as a summary of this, we have proven this pilot scale, this coating technology in a pilot scale, and this is technology that is very efficient. When we have costly chemicals, there is less tendency them to migrate to the substrate. And this is suitable method for nanocellulose applications. We can use nanocelluloses as just, and using a modified nanocellulose, we can create activities to the paper surface. And this, we can also use higher concentrations, and what is important, it's an occupational healthy method. So thank you for your attention.